All right, so now that we've identified our substituents and ranked them, we can determine what kind of handedness our molecule has. So it can be either R or S. This R stands for, you don't need to know this, rectus, which is a Latin word for right. And the S stands for sinister, which is kind of a cool way to say left, I guess. You don't really have to know that, just R or S, be able to identify them. And so let's take a look at a pair of enantiomers. We'll have a H here, a carboxylic acid over here, a methyl group over here, and then an alcohol over here. And then we'll just go ahead and draw the enantiomer on this side. Right, and so what you need to be able to do is look at these molecules and identify whether they're R or the S. What I like to do is what's known as the right hand rule, sometimes the right thumb rule. There's a whole bunch of different methods. You can Google other methods. I don't care which one you use as long as you are able to do this correctly, right? Be able to identify these. I like the right hand rule because you don't have to redraw any molecule. It just uses your right hand, which you always have with you. And so it's pretty useful in my opinion. The biggest mistake people use is not using their right hand. It's called the right hand rule. You have to use your right hand. If you use your left hand, you're going to get all the answers wrong. So yeah, right hand rule, use the right hand. Shocking. Let's go ahead and redraw these molecules down here so we can kind of mess with them. First thing we're going to want to do is go ahead and just rank the priority. So this should be pretty simple at this point, right? This alcohol gets number 1 because it has that oxygen right there. This carboxylic acid gets number 2 because it's got a carbon attached to oxygens. Then this methyl group gets number 3, and then the hydrogen gets number 4, right? And same thing here. Cool. And so what you're going to do here is you're going to take your hand and you're going to point your thumb, open-faced, point thumb to the lowest priority. Right, so if you've got your hand here, your thumb is going to be pointing up at this hydrogen. Right, and same thing here, your thumb is going to be pointing up at this hydrogen. And so then what you're going to do is you're going to make a fist or you're going to curl your fingers. Right, curl fingers inward. And this right here, the face that you're seeing is your palm, right? Because it's your right hand. And then the question you want to ask is, do you count in ascending order? It's a little bit hard to explain, but if you try to do it, it's really not too bad, right? So if you curl your fingers, you'll curl them in this way on either one of these. And here we're counting 2, 3, 1. And here we're counting 1, 3, 2, right? And so you can see on this left side, we're counting on ascending order and then resetting, right? 2 is less than 3, so we go from 2 to 3, and we can't get bigger than 3, so we go back to 1, and then back to 2, 3, 1, right? So it's going essentially 1, 2, 3. This is called R, right? Or this molecule is right-handed. And then in this other one, you see we're counting descending order. We're going from 3 to 2, back down from 2 to 1, and then reset at 3, right? And so this is called S, right? And so kind of left-handed, if you will, right? And so if you're going in ascending order, it's R. Descending order, it's S, right? Assuming you're using your right hand and doing all this correctly, right? And so the advantage of this is that you don't have to move any molecule. All you have to be able to do is point your thumb in the correct order and picture it in somewhat 3D fashion, right? So here's just another example. Right, so we have this molecule right here. This alcohol gets number 1. This carbon with a whole bunch of other carbons gets 2. This carbon gets 3. And then hydrogen, of course, gets number 4. And so what you're thinking about is pointing your thumb back into the face of the hydrogen, right? So point your thumb kind of going into this piece of paper And so if you're pointing your thumb and going into this piece of paper and then you start curling your fingers are going to curl this way, right? They're going to curl this way, and that goes from 1 to 3 to 2. That's in descending order, right? That's not how you normally count. You don't count like that. And so it's S, right? That's just the method I use. All of this kind of comes down to practice. It doesn't matter which method you use. And it's a little bit hard to show on this kind of two-dimensional piece of paper. I'm coming up with a molecular modeling lab, which will show this with kind of three-dimensional images and whatnot, maybe a little bit better to see, but also feel free to look up some other YouTube videos and whatnot. This is a pretty common way to do it, so you can find examples of this, or if you find something that you like better, go ahead and use that.